All right, so I want to go over the homework problems that I gave you. Some of you may have had trouble with these. Just going to recap what's going on here. So if we have a question here, 1, given a population in Hardy-Weinberg equilibrium with the allele frequencies capital A equals 0.9, capital A being the dominant allele, and lowercase a equaling 0.1, meaning the recessive allele, determine the frequencies of the 3 genotypes: homozygous dominant, heterozygous, and homozygous recessive. Keep in mind that these numbers here are frequencies, and we can think of them also as percentages. So in this population, 90% of the population has, 90% of the alleles in the population are dominant, and 10% of the alleles are recessive. So here's the 2 equations we can use. We have p squared plus 2pq plus q squared equals 1, and p plus q equals 1. Remember, p squared, if I'm looking at p squared, that's going to be the homozygous dominant genotype. So in this case, that's going to be capital A, capital A. 2pq is 1 dominant, 1 recessive. That's heterozygous. So capital A, lowercase a, and then q squared we have defined as the recessive, and 2 q's would be 2 lowercase a's. Right, so if you remember, the squares are, p times p, it's just, homozygous. So if we start with our numbers 0.9 and 0.1, all right, p squared is going to be just 0.9 squared, which will equal 0.81. So 81% of the organisms in this fictional population will be homozygous dominant. For the heterozygous genotype, 2pq, you're going to do 2, and then p here is 0.9, and q is 0.1. So that's going to end up being, when you do the math, 0.18. Again, 18% of that population will be heterozygous. And then finally, we have our homozygous recessive, which is just 0.1 squared, which is going to equal 0.01, or 1% of the population. All right, here we're with number 2. In corn, yellow kernel color is governed by a dominant allele, white by a recessive allele. A random sample of 1,000 kernels from a population that is in equilibrium reveals that 910 are yellow and 90 are white. What are the frequencies of the yellow and white alleles in this population? What is the percentage of heterozygous in this population? So we're going to start with just the dominant allele and the recessive allele. So the dominant is yellow, so we have a capital Y for yellow, and that's going to be our P. And white will be lowercase y and will be my Q. If an organism is yellow, remember the genotype can be capital Y, or capital Y, lowercase y. And for white, it can only be the genotype lowercase y. And that is important because in this population, the 910 that are yellow can be either one of these 2 genotypes. So some of them are going to have this recessive allele tied up in there. But the white, the 90 that are white, we know 100% if they're white, they have to be lowercase y. So if we do 90 divided by 1,000, that gives you the frequency in that population of the homozygous recessive, which is 0.09. And remember from our equation, homozygous recessive is going to be q squared. That's your starting point for most of these problems, is finding the recessive, the phenotype, typic recessive, and figuring out the percentage of that. So once I have that, everything else kind of falls into place. All right, this is q squared. If I take the square root of both sides, I get 0.3 equals q. And then if I substitute 0.3 into the equation, p plus q equals 1, that tells me that 0.7 are going to be p, or the dominant, right? This would be the dominant allele, capital Y, 70% there, and that recessive allele is only 30% of the population. All right, that answers this question. The first part, what are the frequencies of the yellow and white alleles in this population? Frequency of the white allele is 0.3 or 30%. frequency of the dominant allele is 0.7 or 70%. And then the percentage of heterozygous in the population, we use 2PQ, which would be 1 dominant, 1 recessive. So that's 2 times 0.7 times 0.3, which is going to be 0.42, or 42% of this population. That's number 2. All right, here's number 3. Looks like I got cut off from when I got out of Jupiter, so I'll just go ahead and do the whole thing. Rabbit's ears can be either short or floppy, where short ears are dominant over floppy ears. There are 653 individuals in the population. 104 rabbits have floppy ears, 549 have short ears. Find the frequency of the dominant and recessive alleles, and we'll figure that out. All right, so here's again our base question, or our base equations, and we have short is dominant, so that's going to be P. Floppy is recessive, that's going to be Q. Going over to genotypes, the short can be capital S, or capital S, lowercase s, and floppy being recessive has to be 2 lowercase s's. We know that in the floppy, right, is recessive, so there are 104 of those out of a total of 653 in the population. That means the floppy the floppy rabbits are a 0.16, 16% of the population. And remember, that's lowercase s, which is our Q squared. So that is Q squared. It's a nice perfect square. That means the frequency of the recessive allele in the population is just the square root of Q squared and 0.16, which is 0.4. Right, so just taking the square root of both sides. P then is found by substituting Q back in its equation. 1 minus 0.4 then we'll get us 0.6. So the frequency of the dominant allele then is 60% or 0.6. Frequency of the recessive allele is 0.4. Let's go ahead and finish this up. The frequency of a homozygous dominant, which would be P squared, would then be 0.36. All right, that would be 0.6 squared. It's 0.36. Boom. And then 2PQ is 2 times 0.6, which is P, times Q, which is 0.4. And that's going to be 0.48, or 48% of the population. All right, so those are all of the different data you have for those. On to the next one. All right, our final question. Petal coloration of pea plants has a complete dominance relationship where purple petals are dominant over white petals. There are 276 plants. 273 have purple petals. Find the frequency of the dominant and recessive alleles and the frequency of individuals with the dominant, heterozygous, and recessive genotypes. Sorry, heterozygous and recessive genotypes. It's basically all of it is what we're going to figure out here. And here's our base equations. There, I've set this up already. Purple is dominant to white, so purple will be P. White will be Q. The two genotypes for purple are capital P, or capital P, lowercase p. And then white can only be lowercase p. Notice in this question, they don't tell us how many white there are, but we can easily figure that out by subtracting the total from how many purple. The only remaining ones will be white. That gives you 3. So you have 3 total out of 276, and that is going to be 0.01. And again, this is white, which is homozygous recessive. That is going to be your Q squared. Now to get Q, you take the square root of both sides. Square root of 0.01, you got it, 0.1. Substituting this back into the equation, 0.1 for Q, P plus 0.1 equals 1. You solve for that, that gives you 0.9 for P. And we want P squared, which is going to be your homozygous dominant. You square both sides. 0.9 squared is 0.81, and that's going to be P squared. And then finally, to do 2PQ, you do 2 times 0.9 times 0.1. That's going to give you let's do it over here. That'll give you 0.18. 18% is going to be heterozygous. So to answer your question here, if we go back to the top, frequency of the dominant allele is going to be 90%, or 0.9. Frequency of the recessive allele will be 0.1, or 10%. The frequency of individuals with the dominant homozygous will be 81%, or 0.81. And the frequency for the heterozygous will be 0.18 or 18%, and the frequency for the recessive genotype is going to be 1% or 0.01 of the population. There you go. Good luck with the problems today.